Hey everybody, Jason here with STS. Welcome to my shop. Today I'm going to be working on another iPhone 6 that was sent here for no image, no backlight. However, this one I'm not going to be so lucky because it does not have a single clue as to what is wrong with it. I mean, it looks like the phone's like practically never been opened. The description I got from the customer, let's see, I don't actually know. I just know that it quit getting an image on the screen. They took it to the Apple store. Apple tried a screen on it and said, nope, it's not your screen. Here's the price. We can swap you out for a different phone, but you're going to lose your data. So this phone obviously has data on it because I can hook it up to iTunes and I can see a human readable name. It's locked with a passcode. So this is a typical no image situation. Only on this one, I have absolutely no idea what I'm up against. Let's switch you over to the microscope. And I'll just let you have a look at this thing. It looks really clean. There's no long screw damage. There's our no image screw hole, our bottom left screw hole. We don't have any tool markings. No liquid damage. As you know, I see some leftover flux here and there on the board, but you know that's just manufacturing. I see a little bit. Let me grab something to point with here. I see a little tiny bit of smudging right here on this connector where you can tell somebody's moved it around a little bit trying to get it to plug in. I see. Now there is some tool damage here. Look at this. This is FL 2024. That's a backlight filter. And it looks to me like somebody might have picked at that already. So overall it looks pretty good. And I have checked it. It's not just a no backlight issue. It's no backlight, no image. There's no image here. I really don't know what I'm up against. So since I don't know what I'm up against, we're going to start by checking some basic stuff. Let's open up Blackfish here. Give you screen capture, adjust this crap to fit my little capture window. Where are we at? Alright, that's probably pretty close. And we've got an iPhone 6 opened up. Let's see if we can get to... That's not... And I don't know if that happens to anybody else, but my search box always pops up off the side of the screen. So I do Alt-Space to open up the little menu at the top left, and then I press M to move it. Now, it won't move with the mouse right away, so you got to hit an arrow on the keyboard once. And then it'll snap to the mouse arrow. Whatever. It's Microsoft Windows has been like that since the beginning of time. I don't know why it behaves like that. So let's search for Chestnut. Let's buzz through here. I'm used to using the PDF schematic, but I haven't went through and removed all the branding from my schematic, so I'm just it pollutes my video whenever I show it. And people tell me, why don't you go through there and delete it? Alright, so here's Chestnut. Now, I'm going straight for Chestnut because this isn't just like a no backlight situation. This is a flat out no image situation. And it's like the Chestnut IC is not coming on. Now, Chestnut is our power supply for all things display. And in order for it to come on, of course, we got VCC main coming to it. And we've got various other signals here that need to be coming to it. I don't know 100% everything that is necessary, but I know pretty well if we've got anything power missing, it's not coming on. If we've got any one data line, it's not going to produce an image. I mean, if any one data line's missing, it won't produce an image. I'm going to check some really basic things here. So let's start by going after some common places for fault. We're going to check filters for a 5v7 line. We're going to check filters for 1v8 line. And I've seen these blow pretty commonly on these things, so let's check there first. The last video I posted, I think, was a 1v8 filter. And so I'm just going to take it, I'm going to lightly pick away some of this coating here. This one here, I believe, is our... Gosh, I don't remember. It's 1v8 or 5v7. This one here is either... Okay, this one here is our 1v8 filter on this side. This one here is going to be a 5v7 filter, and we've got some other ones mixed in up here as well, but let's get a check on this thing. I've got my multimeter set to ohms mode, We're going to check this first filter. Oops. I get 0 ohms. Well, as close to 0 ohms as I get. This old-ass multimeter of mine reads 0 ohms at around 1. That's probably one of the next things I'm going to upgrade. Man, I've had this since I was 14. I mean, 14! This was a Christmas present, and I've been using it to solve... Oh my gosh, this thing has been through it. It has absolutely been through it, and with everything that I've done, Tesla coil-wise and high voltage-wise, this is the one multimeter out of my whole entire arsenal of multimeters that never got fried. I mean, whenever I was 17, there was a point in time whenever I had, gosh, somewhere between 5 and 10 of these suckers. All I would run simultaneously to monitor different parts of my wicked Frankenstein circuit. So, alright, back to this repair. Did I check both of those filters? Okay, I got 0L on that one, but it might have been the rubber. Yeah, it was. So we got 0 ohms on that one. We have 0 ohms on this one. No image on the screen. Just poof, out of nowhere. Dropped image. For no reason. Can you see where that shield is broken loose? See where that moves? I didn't notice that with my first initial inspection, but you can see that shield is actually broken loose from the board. This is going to be something that happened from an impact. Yeah, we're broken loose. One day I'm going to get a really bright light on this scope. Alright, so we're actually, yeah, we're broken loose all the way down. Not right there, but right here, this is broken loose. So, that just doesn't happen by magic. That is broken loose because something broke it loose. Which means the phone didn't just spontaneously quit getting an image. It got slapped real hard, and then it quit getting an image. So let's get a look here closer to our connector. Okay, so here's our display connector. Here's the filter I checked. That's our 5V7 filter. We checked this 1V8 filter here. We also need to be checking those lines for a short to ground. And we have quite a few data lines out here. If any one of these filters are not getting what they're supposed to be, you know, if any one of these are blown, we're not getting an image. There's a lot of stuff here that can cause us to not get an image. We have to have LCM. We have to have this chestnut enable signal. This has to be present. We got to have the LCM reset signal. That has to be present. These are signals that I'm used to dealing with whenever there's bottom left hole long screw damage. I forget that I'm not on screen capture because I can see my screen. So yeah, we've checked these filters here, but none of the other ones. Watch me turn into a bumbling idiot for this video. I mean, if I performed the way I do in videos in normal day-to-day repair, I would be in trouble. I mean, I would be in absolute trouble. Anyways, you'll never believe me. One day I'll get comfortable enough doing this on camera that I won't screw it up so bad. Okay, just real quickly here, I'm checking to make sure this 5V7 line here is not shorted to ground. And on this side of it, I get 1 ohm to ground. Okay. And then on the ground side of it, I get 0 ohms to ground. Wait, am I looking at that right? Oh, what a day. It's been such a long day. Like, I'm treating this like a capacitor. Some video. Alright, so let's check our 5V7 line. That is a filter, so either side of that going to ground is bad news. and it is actually 0 to 1 ohm to ground. Okay, so we know we have a short to ground here on the 5V7 line, but we don't know exactly where it's at. So if we get to poking around on this line and we look at both sides, we have right here next to the filter there are two capacitors. One of those capacitors is on the inside of the filter and one of them is on the outside of the filter. So one capacitor on the connector side, the other capacitor on the supply side, and then we also have this other capacitor up here that's also on that 5V7 line. But we do have the 5V7 line here that is absolutely shorted to ground, and we don't have the foggiest clue where it's at. Let's check the other side of the board and see. If we've got any other places where that pops up. I don't. Let's get off the connector side of that. Okay, we have one other cap here on the back side of the board. I thought there was one on the other side, so there's a possibility that it could be this one as well, but we really don't know which capacitor that it is. Okay, let's see if it is one of the easy capacitors to get to. Let's go after the easy ones first. So, if we're lucky, I can do this repair and move on, and then I won't have to take the board out of it. But you know the way this goes is that I'm going to do all this work to try to keep myself from taking the board out of it, and then I'm going to have to take the board out of it anyways. Alright, let's get us a little shielding here. I don't know how many of you have seen one of these these LiPo batteries go up whenever they've got a good charge on them, but that's a sight to see. That's spectacular, especially if you're not expecting it. I've actually never done it in the shop, but we did it outside of the shop once. My son and I was just gonna see what would happen if we punctured one, and by the time I made it outside, he had already nicked it with an ice pick, and man did it put on a fireworks show. Oh boy, it went up like fireworks. All right. I'm going to do all this work shielding this, and then I'm going to have to take the board out of it anyways. All right. There we go. This back shield here, that's just to keep my heat off of the power button flex. Okay. Yeah, so I'm not going to pretend to be better at this than I'm not. Whenever I run into an issue and I don't have image on the screen, it's just you don't really know what it is. Sometimes I'll get lucky and open it up and be like, oh hey, there it is right there. That's good video material there because you already know sort of like you already know how to solve it. As soon as you see it, problem solved. You got something to go by. But whenever you open one up and there's absolutely no signs of liquid, there's no symptoms, there's no visual anything to go by, the only thing you have is electrical. You only have electrical measurements. That's the only way you can narrow this down. And with the schematics, a lot of these lines highlighted in black, like these bold lines, these are mission critical lines. You know, this is power here, so I know we don't get an image on the screen and we don't get backlight, so we must have something going on at the core of the display, which in this case is chestnut. This is our power supply for display. So as far as where I started, that's just a matter of where I commonly see them screw up. So let's go ahead and move in on this thing. Hopefully I taped it in a spot where I can still get to it with the microscope, since that's kind of the whole point of turning my cameras on. And we decided it was 5V7 that was shorted, which is our bottom right filter there that I cleared off. Now I don't know which side of this filter has a short, I guess if my multimeter, like if I had a decent multimeter, I could probably use resistance to decide which side had the lower resistance and which side had a higher resistance, and with that I could figure out which side of this filter the cap is blown on. You know, it's always such a guessing game which cap that it is that's blown. It's either going to be one of these two. There's another cap over here that it could be, and then we have one on the other side of the board that's all on that same line. Now, you know, it's possible that it could be getting shorted through the chestnut IC itself. That's the guessing game that we're playing here. Let's just see if I can use my voltmeter to narrow this down. See, I could pull the filter in this case. If I remove that filter, that 5E7 filter, that is on ZXW tool here. One side of that filter goes to this cap, and then the other side of the filter goes to this cap. So if I removed the filter, I would only see a short on one of these caps and not both of them. So removing the filter would reveal which of these is shorted. So it would either be this cap or this cap. You know, say the filter is out of the circuit. It would be this cap, or this cap, or this cap, or this cap. So we have 4 here that it could be top side, and then one on the other side. And right here, like if I took out the filter, it would be either this one, or the one on the other side of the board. Is that confusing? So there's 3 possibilities on this side of the filter, but only 2 possibilities on this side of the filter. So we've got a higher probability of it being on the powered side of the filter and not the, what do you call it? Not the service end of the filter, not the side that goes to the connector. So let's see. I'm set on ohms here, and I'm going to see if I can tell which one of these caps is shorted. We get 2 ohms even on my meter. .7 on my meter on this side. So let's go back here. This cap 1.92, 1.92. This cap 1.7. A little bit of a grind here, make sure I'm getting a good connection. 1.9, 1.7. So I'm getting a lower resistance on our middle cap. Okay, which means it's one of the 3. It's not going to be on the inside. It's not going to be on the service end toward the connector. It's going to be on the outside coming in. It's power coming in. So we have narrowed our guessing game down a lot. We've went from 5 possibilities down to 3. We know it's going to be one of these 3. Now at this point in the game, it's a guessing game. We're going to go ahead and peel a little coating off of this other one over here. It's nice when you peel the coating off and you can clearly see something different, but with these low current shorts like this, you just don't get the luxury of them getting completely smoked and burnt. So let's go ahead and check this one over here. .8. Same reading. Okay, so we are going to start pulling caps. Let's get some flux on the situation here. This is Chip Quick SMD 291. Every tool that I'm using here is linked in the description. And if you use those links, it does actually put a little bit of money back toward this channel and helps me create more videos. Okay, so the first thing I'm going to do is see if I can't pull this middle capacitor out of the loop here. Maybe I'll get lucky and it's going to be that one. You know what's going to happen? I'm going to go through all this trouble of shielding and stuff, and it's going to be the one on the other side of the board. Especially since I'm recording a video. It's going to be the one on the back of the board. One of these days I'm going to add tweezers to my arsenal. Alright, I was a little rough on one of those pads, but it's going to live. Some people remove these caps and don't even use heat, just flick them off the board. Alright, we're not going to make that pretty right now because we are just checking to see if I have relieved a short. And if I was paying a little more attention and didn't just do my normal flick it off the table into the trash, I would have saved that cap so I could test it. Alright, let's see if we still got short to ground here. Okay, 0 ohms to ground on that side, but I think that is actually ground. And on this side we've got 0 ohms to ground, which means we are still shorted. So let's go ahead and move over here and pull our other one. Yeah, so this, you know, they said it just happened out of the blue, but this didn't happen out of the blue. Well, it could have, but the shield being cracked loose, that didn't happen out of the blue. This phone got slapped. Okay. Do a little flex on the situation. My favorite flux applicators, toothpicks. That capacitor just popped off my tweezers. And you didn't see me get any solder on that connector either. Do we still have a short to ground? If we still have a short to ground, the board's coming out. Alright, one probe on ground. .8 ohms. And 0 ohms. Any one of these readings on my meter is a rough estimate. I'm going to be replacing this thing really soon. But anyways, everything there is below 2 ohms, which means our 5V7 line is still short of the ground. All this shielding, man. Every time I do this, every time I do all this shielding, I wind up throwing it all aside because the board's coming out of it anyway. I think I really would, in the long haul, I would save time by not shielding it like this and just take the board out. Save all this time. Jeez. Alright, so let's grab us a screw holder. There we go. And pull the board out. Oh, you know what? I always do that. We already have a screw holder. Yeah, so really a lot of what takes place in this business, like, you wind up getting smarter. You wind up knowing how things behave. That's why whenever I seen that we have absolutely no image at all, I went straight for mission critical power lines. You know, it's really, really common for that 5V7 line over there to get shorted to ground. I don't know why. Maybe the caps are junk. But it's really common to find that shorted to ground. Only a lot of the times I'm lucky enough and it's a topside capacitor, and there's all these different things that can cause it. So when you start talking about a no image repair, there's a lot of different things that could be. And the first thing I check is long screw damage, because that's what it usually is. Okay, got just a few more screws here to take out. I normally don't move things around this much, but I'm actually making an effort to keep this stuff in front of the camera. Although the teardown portion of this video is really sort of unimportant, I'm probably going to leave it in here anyways. Okay. That was all of our main screws, and then I separate the last screws, the board only, you know, just the screws through the board. I put those down here into this pattern. And that's how I do not lose track of my screws. Everything gets laid out onto a screw mat in the order that I take it out. But honestly, even if they do get mixed up, like if one of these pads gets knocked off the table or something gets shoved across it, I've done this so many times that these screws go back in. Even if they're not in 100% the right place, they go back in the safe place. So, alright, I am going to disconnect one more coax here, and then I am coming to the point here where I need to say thank you to somebody. Here is my recent tool to the shop. This driver. The other day we got a mail-in in the mail. Angie opened the incoming mail and she's running our check-ins and putting stuff on the shelf. And she's like, honey? And she held out this driver, and I knew from across the room what it was. Somebody got sick of me using a flathead screwdriver to take apart iPhones, and they sent me the proper standoff tool. So, that being said, Woody's Phone Repair, LLC. Fred Wooding, this is Wooding's Phone Repair, and Cortland Manor, New York. Thank you. This is really awesome. I opened this thing and I used it the first day that I took it out of the package, and honestly, it's one of those tools where I don't know how I lived without it. So, Fred Wooding, Woody's Phone Repair LLC. See if I can get this on the screen. Thank you. That's been a really big help, and it is such a tool that it grips these things so well that you accidentally pick up the phone by it. You see that? It really, really grips these well. So it's not just like, you know, to me it doesn't seem cheap at all. This sucker It's really solid, and I can picture this tool lasting for a very long time. So, as you said in the note that came with it, I'm sorry I don't have that with me, or I'd read it out loud, because this kind of stuff, this is really appreciated. But as you said in the note that came with it, you expect to see me use it in a video, but this sucker gets used 100 times a day, so maybe 500 times a day. So let's move on. Let's see, that was the last screw, so let's take the board out of this thing. Yes, Wooding cell phone repair. I've had a couple of shops that send me stuff, and so far it's been stuff that is so useful. It's just like, why didn't I just spend the $6 2 years ago? Jeez. All right, so we're going to sit the housing out of the way. We're going to get our screws out of the way, because you know if I don't, I'm going to slap them with something, and then I got to sit here and figure out who's who. And then, okay, so just to recap, we have removed, let's do this on ZXW tool. Dude, what if my voltmeter is trolling me? And we are in fact getting continuity through this other cap. Before I pull the sticker off the board, let's try it. You know, let's try it. I should have done that anyways. I should have pulled the filter, and that would have revealed which side of the filter the short was on. Okay. So we pulled this cap and this cap, but we didn't touch this one or the one on the other side of the board. I guess another way I could figure it out is to apply power and see if the filter smokes, and that would reveal which side of the board it's on, wouldn't it? Okay, so with all the other caps off the board, this cap is measuring, and I'm not getting a low battery alarm on my voltmeter either. I got 2.0 ohms across that cap there, and across where this cap used to be, 1.7 ohms. It is consistently lower, so I'm not inclined to think, I really am not inclined to think that it's going to be this cap. That reading tells me that we are getting a better connection of electricity here. You know, a lower ohms reading is more connection. It's allowing more electricity to pass through. So I'm getting more electricity to pass through between here and here than I am between here and here, which tells me that in order to get from here to ground, it's most likely going all the way through this filter and catching ground on the other side. And we know it's not this cap because it's gone, and we know it's not this cap because it's gone. The only other cap that it can be is on the opposite side of the board, C1569. Let's check C1569. I'm not going to do any more work on the front side of that board, because I try to do as little as possible. That's the only way to do any of this profitably. So let's get our sticker off the bottom. Come on, autofocus. Nobody wants to see that blurry crap. And I don't have an extra hand to focus you all the time, so you're gonna have to do it on your own. There we go. Nice clean sticker extraction. Alright, so here we are. Board's out. We're gonna lay it over here in my service area, all the burn marks. I'm gonna go ahead and flip the board over so that it's turned right. Oops. On the screen, and here. Watch me go through all this, and then it's going to be chestnut short of the ground. I probably should have pulled the shield already. Okay, so here we are. Now you can see down there in the bottom right, that's our board. And you can see we've got these three here, two like this, and then this one here is what, perpendicular? Is that what you call it? It's not parallel, it's perpendicular. Dicular. And then we go from this to the right, we've got a cap there, and then the next cap down, that's our 5v7 line. So we've got the Three Stooges here, we've got this cap, and then our next one down, this one is our 5v7 line. Now that, I'm not going to try to cram anything down in there and try to dilute that solder. We're just going to get in there and do some straight hot air to take that off the board. I am plenty comfortable enough with hot air to do that with hot air. So let me give you microscope only. And we're going to put a little dab of flux in there. Put the right one. Okay. Let's start heating this dude up. Wait. This is where having a cheap hot air station bothers me. I'm sitting here waiting for 390 to roll around on the dial. And that takes forever. Compared to having a preset where I could just turn it on and be there. That's why I would upgrade hot air. This stuff about not being able to do this work with a cheap low-end hot air station, that's bull. I mean, when the iFixit article came out and featured iPad rehab, STS telecom, micro soldering, I had been through I don't know how many dozens and dozens and dozens of these repairs and was advertising it as a service. I was using a $60 hot air station, that died on me because it was a cheap piece of shit. But nevertheless, I guess what I'm trying to say is that it's not so much about the tool itself as it is about the tool using it. I mean, it's not so much about the tool itself as it is about the person using it. So I have no problem with this $129 hot air station. It has made literally buckets and buckets full of money. My shelves are stocked with repairs. Things move fast. It works like this. Why would I spend $600 or $800 or $2,000 or $4,000 on hot air when I've got something here that heats up in a snap and makes really, really short work of these repairs? And if it quits, I'm not stuck sending it off for repair. Like, I can just go buy another one. And I can afford that. It's not going to break the bank if my $130 tool breaks. Anyways, so back to this repair, and just as a demo, okay? This is a single cap. Yes, I know I'm using way too much heat on this one cap. Let's get you focused here. The best that I can. Are my tweezers small enough to fit down in there? Barely. We can do it. Alright, so I'm at 390C now, and I'm not anywhere near maxing this station out either. Right now, I'm slowly working up the temperature of the board. And I'm just about to the point where I'm going to move into for the kill already. Okay? Off the board. Okay? Now, I would like for somebody to tell me if a $500 hot air station or a $1,000 hot air station is really going to heat that up and do that job any better. I mean, really? Come on. Hot air is hot air. There's not really different qualities of hot air. Now, the thing that I do find out that really does matter, and I learned this going from a $60, which I still keep on the shelf for sentimental values, going from that really, really cheap station to another cheap station, is that this one, it has a really heavy element in it. So it does take a little bit of time to heat up, but not much time, maybe 20 seconds, 15 seconds at the most. Compared to the $60 station, it had nothing but a wrapped piece of wire in it, and that would produce really sporadic temperature changes. Compared to this one, it's got a lot of drive behind it. The temperature doesn't change really easy. So I've got really stable controlled hot air out of this $129 station, and I'm going to save that for topic for another video. Let's move on with this repair. As you can see, we have now removed that capacitor. Let's switch back over to the other side of the board here where I've been taking my measurements, and we are going to check our measurements. Yeah. Yeah, I can't help it. It gets under my skin a little bit to hear people say, you can't do this with a $129 station, or you see this? You're not going to get this out of a cheap station. Bull. You are too. It's all about your feel of the thermal mass. It's about your feel of the temperature, your feel of how the temperature flows. The equipment, you know, that is a big part of it. You can't just use something that doesn't work, but you can use something that works good enough if you know what it is that you're looking for. So let's see if our short's gone. Let's just check right here where this cap used to be. And I now have 60,000 ohms to ground. 5 volts is not going anywhere through 60,000 ohms. So we have relieved the short. We're at 190,000 ohms on this side, which is the same line. It makes no sense. So let's check back over here. And this is just from the board changing temperatures. That's what it is. Yeah, we're over 200,000 ohms. So that is a short removed. Let's see if we can find some caps to put back in these places. So first, let's clean up our sights. I'm going to anchor my board down here so that it doesn't slide around. Yeah, I started with nothing. I mean, whenever I started doing electronics repair, well, let me take that back. I've never known anything but electronics repair, but whenever I started doing phone repair, I had nothing but a hairdryer. And I started taking walk-in repairs with nothing but the packet of screws that came with the new screens, or the packet of tools that came with the new screens, which I've got boxes full of them. I don't even know why I leave that on the top shelf. It's a box of those little packets. But I started with that little packet of tools and a hairdryer, and that's what I was replacing screens with. I was doing glass only on. Let's move on. Let's move on with this repair. That's a point in my life I don't miss. I love doing these board repairs. I'm passionate about it. Okay, I'm going to switch tips here over to something that has a little bit more length. And we are going to use a little hot air on this since we have ground involved. I'm going to try to get all that in one view so I don't have to move it. Okay, and let's get in here and try to shine up these pads. I wonder if I can use wire this time. I'm all the time using, you know what? No, because I need hot air. What I wind up doing, I wind up putting flux on the board. Like this spot here, I'm going to put flux on the board, not on the connector like I just did. I dip my iron right here in solder paste, and I start heating up the board, and I use heat from my hot air at the same time. And it makes those pads fluff up really, really easy. See, I just bumped them, and those are good. So let's move right over to this side. I'm going to apply some heat here and begin picking away with this with some tweezers, because we are kind of, you know, we've got this rubbery crap in the way. Okay, we'll add a little bit of fluxy flux. Alright. You waste so many toothpicks. I'm just kidding. Nobody's ever said that, but I do. Man, I go through piles of toothpicks. Too much solder. Okay. Those are nice and fluffed. And let's grab some parts. see, I don't want to use my iCloud board. This is my test board that works. I got several of these boxes. Yeah, what I'm trying to do here is keep from looking at the value of each one of those caps and trying to make them match. Like if I just grab a donor board that's got those on there, I will just swap them right on over. They're all missing those components. Somebody needs to order parts around here. Alright, let's pull them off of this board. Yeah, so all this talk about these cheap stations not being consistent on temperature, I mean, keep in mind, I'm doing this with a $129 AOE station that's linked in the description. The exact one that I'm using is there in the description. And here comes that cap, boom, off the board, okay? That one, we're going to go ahead and slip over here. We're going to grab this one, boom, off the board. See? Now, I can't tell you how I would feel if I spent $4,000 to do that instead of $129. I wouldn't feel very good. Maybe one day whenever I'm just like loaded and maybe one day when I'm loaded and just want to spend the extra money, that's different. But to spend that kind of money right off the punch, like if you're wanting to get into this business and start doing this, I highly suggest buying cheap tools. Not too cheap, not cheap. Don't skimp on your iron. That Hacko station, that really is a pretty low end station, but man, I love that thing. And it behaves very consistently, just like my hot air does. So, you know, $200 station, $130 hot air station. I'm sitting here running big time repairs. I mean, I'm cranking through, anxiety. Lots of repairs, guys. Lots and lots and lots of repairs on this cheap equipment. Alright, let's resituate because I blew a component off. And that didn't have anything to do with my cheap hot air either, trolls. Now, since I've changed the alloy here over to leaded, this is actually going to melt quicker than everything around it. What's going on here? It seems like I got something under it. No, you know what's happening? It's because I bragged. And now it's coming back to haunt me. I probably should have tinned my component too. Okay. We're going to stop right there. That was way, way too difficult. You know what I think it is? It might be the rubber that I've left behind on these components. Okay. A lot of these components, these really common components, are things that you should be stocking, but you'll never stock every component on the board. So just be prepared to use donor boards. Okay. And that one's on there. Let's go ahead and flip that board over. Kick it aside. We're going to flip my donor board over. And we're going to grab our backside cap instead of the side, because I didn't tin the pads on the board that it's going to, our customer side board, yet. So let's grab this cap. This is the one that we need. Now this is a working board, so I'm going to work it up slow. Well, not working board. It would be working after I put Tigris, TriStar, and a whole bunch of other shit back on it. Then it would be a working board. And now 5V7 caps for Chestnut, and that other cap I knocked aside. Alright, so we'll set that board off to the side. We're going to sit our component somewhere here where I know how to find it, but not going to get blown away hot air, so I'm going to put it right down in there in between the shield and the NAND. Okay, so we have that stashed, and I'm going to get in here with some flux. The flux is drying up. Yeah, when I first started doing this, I was scared about my hot air station. I was scared to show people what I was using. You know, I just thought I was going to be a laughing stock. But you know what I come to find out is that with the amount of success that I see with this, I have more of a problem with my camera turning on this microscope than I do with this hot air station. The amount of success that I have out of this station is just, I don't care what anybody says. $130, and if it breaks, I can afford to go buy one. I don't have to. I'm not. Alright, that's a little grungy on the solder down in there, but we're not going to be picky about it. I'm going to put flux in there on top of that, and then I'm going to move right on in and drop our new cap in place. Okay. Whoops. I laid that where my syringes go, and that is nasty. Alright, so our cap I stuck down here to keep it from disappearing. And it's going to go right down in there. And if surface tension is friendly with me today, it's going to drop onto its little home there all by itself. Come on, be friendly. Friendly! You know you want to be friendly. Thank you. Alright, so that cap is back in place. Let's let this board cool off. I'm going to check my cameras. Okay, so we have put that 5V7 cap back in place. We've put that one back in place. And we put that one back in place. So, question of the day. Do we have any shorts? Zero ohms on that side. And we're in the mega ohms on that side. So weird that it didn't give me that reading before. Probably because this board's still really hot. Something weird's going on. And then 0 ohms on one side, open on the other side. We are good to go. All of our shorts are gone. So let's pop this board into a test housing. Yeah, the shorts are gone and the caps are replaced. Now, you might be able to get away with not putting those caps back on, but who wants to screw around and take that sort of a gamble? Me, I can't sleep at night. I was watching a Chris Long stream, and for those of you that don't know Chris Long and you've tried to search for him on YouTube, if you type in Chris Long, what do you say, iPhone? Type in Chris Long iPhone, and then he'll be like the first hit. Otherwise, if you type in Chris Long, you're going to find a bunch of stuff that has nothing to do with repair. All right, let's grab a better test screen. Okay, let's not use a battery. I don't know why I still put these all the way in the housing. Probably just because I wind up testing it and doing other stuff with it. So let's hook this up for the supply for the sake of this demonstration. And also so that I know if I still don't get an image on the screen, I'll know whether or not the damn thing's booting. Okay, we're at 3.9 volts and 0 amps. We're connecting battery. We're still at 0 amps, so we know that this thing is not drawing power with power off. And we are going to push the power button. Are we going to get a display? Before it was no image, no backlight. Now it is 100 milliamps, 200 milliamps, the phone is booting, and we have image on the screen. So what happened was, you know, I would say that it just magically happened, but that does happen. Sometimes capacitors can just go, you know, a capacitor is a void. It's conductive here, and the space between the conductors, the dielectric between the conductors, is where the capacitance occurs. Now, I don't know if I'm explaining that just right, but that's capacitance. You know, you've got a conductor here, energy stored in between is capacitance. And these little capacitors, you know, the plates or whatever, I don't even know what's inside them, but they just decide they're going to close one day, and all of a sudden you wind up with a phone that, the hell is that? You wind up with a phone, or you wind up with a closed circuit whenever it's supposed to be open, providing this buffer of charge between the two plates. Okay. There you have it. This phone has data. This phone has a working screen. But it does have a severely dead battery since that's my test battery. So I'm going to go ahead and slide the power off. We're going to set this phone aside. I'm actually going to charge my test battery a little bit. So anyways, if you have an iPhone 6 that has no image on the screen, there's no long screw damage, there's no visible signs of anything burnt, it's just no image, your only option is to track it down through diagnostic measurements. You know, there's a lot of stuff that can cause no image, but chances are it's probably going to be a shorted capacitor somewhere. And so just to recap what I did here to fix this one, we had, you know, because it was easier, I went straight after these two capacitors here, and one cap is on one side of the filter. See, each of these capacitors, one side is ground. So one cap is on one side of the filter, the other cap is on the other side of the filter. And by checking with ohms, I decided that I had less resistance on the supply side of the filter than I had on the service side of the filter, which tells me that the short must be on the supply side. So I started by removing the first cap on the supply side here, C2051, still had a short. So I went to the next cap, we had C2070. Still had a short, so from there I wasted all that time with my shielding and had to pull it all loose and ventured to the other side of the board to C1569, which was actually shorted. So here we go, this cap out in the middle of the board in the back, in the middle of billions of other capacitors. This one little capacitor decides, I'm going to close the circuit today, and that's it. No display. So there you go. This phone is fixed. That is going to be it for this video. I really hope you all have successful repairs. I thank you for watching, and I will see you next time. Have a good day, everybody.